And welcome everyone to Beyond the Forecast. I am Chief Meteorologist Michael Stevens, and today you're going to get a very heavy me show. And that's because I'm going to take you into fronts: cold front, warm front, occluded front, stationary front, dry line, everything that you usually see on a surface map. What gives you warm air, what gives you cold air, what gives you the same weather over and over for a few days, and also dry conditions. What do these mean, and how do they impact you? So we are going to break down fronts. Meteorology 101 from me. So we're going to show you that today, but then we're also going to jump back into a brief look into our live streaming Beyond the Forecast podcast, which you can catch every Tuesday. But before we jump into Meteorology 101 and everything you have to know about fronts, let's talk about this day in weather history. So this day in weather history, May 28th, 1942, the latest snowstorm on record happened for Iowa. So Iowa's latest snowstorm of the season happened May 28th, 1942. 10 inches of snow fell for Le Mars, and many areas surrounding that, Cherokee and other spots, saw 7.5, 8 inches of snow. Daytime highs for that afternoon were only in the low 30s. May 28th. Can you imagine? May 28th, 1942. It snowed 8 to 10 inches in Iowa. Whew! Don't take me back then. I don't want to go there. Once we get time machines up, I'm avoiding Iowa in late May of the 1940s. Tuesday, we wanted to know, trivia time, when does meteorological summer start? Is it June 21st, May 15th, June 1st, or July 1st? June 1st. That is when meteorological summer starts. The summer solstice is June 21st-ish, because it can be the 20th, 21st, 22nd. But meteorological summer is for the purposes of the National Weather Service and record keeping. So you start on the first of when that season will hit in that month, and then you go 90 days out. That is the season. So June 1st until the end of August is summer, meteorological summer. And it's much easier to keep records when you're just doing it from the first of a month and 90 days out, rather than trying to jump to when summer officially starts and then finding when fall officially starts. Much easier for record keeping that way. Today, we want to know, when does hurricane season normally end? Is it October 2nd, November 30th, November 15th, or November 1st? QR code. Hit it with your phone. It'll take you to where you can answer, put in your answer, and we will give you the answer tomorrow, right here on Beyond the Forecast. All right, viewer photo of the day, brought to you by Great Rooms. And we've had pictures from Cheryl on many times, and here's another amazing photo from Cheryl Goff. She titled it, "One Huge Eagle's Nest." This is an amazing nest. Look at that, 2 eagles, and that nest is almost 2 trees wide. That's an amazing picture. Thank you, Cheryl, so much for sending that in. And as always, thank you to Great Rooms for sponsoring viewer photo of the day. All right, it's time to take you back to Meteorology 101. Get those thinking caps on. Let's talk about fronts. Cold front, warm front, occluded front, stationary front, dry line. Whatever it is, we discuss what it is and how it impacts you. What weather will you see from these fronts? Well, we'll have that coming up right after the break. And welcome back, everyone, to Beyond the Forecast. Now, today we are going to be talking to you about fronts. Cold fronts, warm fronts, occluded cold fronts, warm fronts, stationary fronts, and dry lines. Why? Well, you see them all the time on the maps, but what do they mean and how can they impact you? Right, let's give you the science behind all of the fronts. So first up is cold fronts. The basics of a cold front. You have cold air, and that front is slicing into that warm air. So that warm air is moving up over that cold, and that cold front is forcing that warm air up. So as that cold front slides through, it starts to tends to start giving us clouds, rain showers, as well as thunderstorms, because all that warm air is being thrown up into the atmosphere quicker. So you have that steep frontal boundary right here, that slope. That is where that cold air is just continuing to roll in, while that warm air is moving north, or I should say up. I say north because that's just the direction that you tend to go here. But there's that cold air, and that cold front continues to move through, giving us wind change, usually out of the northwest. That's dropping in that colder air, and that warmer air on the front edge is moving in from the south. This is how we typically see a cold front moving into northern Michigan. Usually associated with the warm air is a warm front. Behind it, that cold front. And that is where you get that cold air diving in from the north, changing our wind direction, changing our temperatures, but also providing with it usually showers and thunderstorms. And in the winter, usually snow showers. So there's that cold front attached to that low pressure system. So here's a look kind of what you would see, the impacts from a cold front, like I told you before. With that cold air moving in, it's surging that warm air up. And as it gets higher in the atmosphere, it starts turning in those clouds, starts turning in those showers, starts turning into those thunderstorms. So you get that storm development with that rising air along that frontal slope. So the stronger the cold front, the higher, the faster that warmer air goes up, and the bigger the storms are that you usually see. So if you have 80s, 90s out in front of this cold air, and then let's just say that cold air drops your temperatures into the 60s and 50s, well, that's a pretty strong cold front. So that bigger slope is going to slingshot that warmer air faster and much higher, which means bigger storms. So that's what you tend to see in the summer with rapid storm development, is usually a stronger cold front, and that is the impacts of a cold front. So let's now turn our attention to warm fronts. Warm fronts is where that warm air is moving over the cold air. So the gradual front, it's not as steep of a slope as a cold front is, because cold air sinks, warm air rises. So that colder air is moving more dense, or that warm air is moving over that more dense cold air. So eventually you'll start seeing those temperatures change warmer. It's not nearly as quick of a changeover as when cold air moves in. So that warm air moves in, and then you see the gradual change into warmer conditions. So again, when you typically see this on a surface map, there's a low pressure system, cold front behind it, warm front out in front. That warm air is moving to the north, slowly starting to mix in with that colder air or the temperatures that you've been seeing. So that wind direction changes, usually in favor of bringing in warm air. For us, it's usually southeast, south, or southwest, and it's bringing in that warmer air. And usually you have typically easterly winds at the surface, and that's because of this low pressure system. That's where you typically see that air out in front, out of the east. And then once that front moves through, you see it out of the south, which is bringing in that warmer air. So behind the front, typically that southerly surface winds. So in front of it, you're at the hands of the low pressure system, so that's why you're seeing those easterly winds, and then you start seeing them change more southerly, bringing in that warmer air. So what are the impacts of a warm front? Well, you see that overrunning air. Some warm fronts cause temperature inversions, which we've explained to you before, where you see, like on water and land, that cooler air, warmer air, and fog. But some warm fronts aid in wintry precip. For us here in northern Michigan, when you see a warm front move in, that can give us freezing rain. That can give us sleet. Usually it's the cold front that gives us snow. In front of it, the warm front is where you start seeing those inversions, and you can have snow, change to rain, change to freezing rain. That's what a warm front will usually do for us in the winter. And some warm fronts aid in elevated storms. And that's because it is shooting, again, those warmer temperatures up. But the gradual frontal slope, definitely much different than you have the cold front, where the steep slope, and it's shooting that warm air up higher into the atmosphere. So now let's talk about occluded fronts. Occluded fronts are just a little bit different. It's not a warm front, it's not a cold front. They're actually connected at this point. So, very cold air, you have a triple point here. You have cold front, warm front, and then the occluded front. The occluded front is what you typically see as purple on surface maps, because blue and red, purple. So you have the triple point. You have warm air, cold air, and very cold air. That is what the cold front, or occluded front will bring to you. So that warm air moves over that cold air. Cold air is more dense than warm air, so it's down here to farther south. And then you have that occluded front move through, and it's just like really an abbreviated cold front. So occluded fronts, you have the wind direction staying the same with the cold front, But notice on the front side of it, it's joined with the warm front. So an occluded front is just a conjunction where they meet and then just goes up to that low pressure system. So on the front side, it's like a warm front. On the back side, it's a cold front. So it's not, you don't have the little bit of time in between a warm front and a cold front that you do with an occluded front. All of a sudden you're warm, and then all of a sudden you're cold. There's no room where the junction point is, like with a warm front and a cold front. It's just a line. So it's a very distinct line between warm and cold. So there you go. Occluded front typically changes your winds from the east or south out of the northwest. What can you see out of an occluded front? Well, just like that triple point that we showed you, what you can see is warm air pushed above both cold air masses, and the thunderstorms will develop, and you'll see cold front, but more, you'll see that thunderstorm activity like a typical cold front, but more precip than typical warm front. And that's because you're dealing with one front rather than two different fronts. So what you're seeing at that triple point is that warm air rising. You'll tend to see more just rainy conditions with this rather than severe weather. Where you typically see severe weather is a warm front moving through first and then a strong cold front moving in behind it. Where you have the occluded front, it's not nearly as cold, or I should say as steep of a slope, pushing that air to the north. So what you're seeing is that moisture rising, but it tends to be just rain showers, maybe a weak thunderstorm. You're not getting severe weather with an occluded front. The severe weather is usually notched in between a warm front and a cold front.
And I'll have more on fronts coming up for you right after this short break.
Now, stationary fronts. This one sounds a little bit different. And this is where you have the cold front and warm front kind of together on a surface map, but you see the reds and the blues connected. They're not purple, it's not occluded, it's stationary. And it does exactly what the name says. It's stationary. There's no front movement. So you have that little to no frontal slope at all. It's cold air, it's warm air. There's really no movement to it. There's no forcing, so the warm air is not creating thunderstorms. And the cold front, well, it's not really dropping your temperatures all that crazily. So that warm air rises. There's very little different in temperature, so there's not a whole lot of dense air. But here's a wind direction change. South winds, north-northeast winds. And the reason being is, one, there's no forcing here with this front. So it's just allowing that air to move freely. And that's where you get that low pressure system. Usually on the northwest side of this, you have high pressure systems. And that's what's kind of keeping it stationary. So what do you get from a stationary front? What impacts do you see from a stationary front? Very little. Again, little to no frontal slope means, yeah, you just get some clouds. That's about it. So the strongest lift occurs for a prolonged period of time due to little front movement. So you could be looking at rain just hanging around and staying and no change. So you could have some flooding and days of rain and thunderstorms to follow. Or you could just be looking at high, thin clouds and not much going on. Kind of like high pressure, but not nearly as sunny and warm. So you get really just stationary weather. So whatever's happening at that frontal boundary is what you will see for a prolonged period of time. So there's a stationary front for you. Now, the last one is dry lines. Dry lines, we definitely don't see nearly as much on a surface map, but it's part of it. So moisture, that moist air, rises up above the drier air, which is the dry front. So you have the dry line moving to the east, and you can see the slope is like a warm front, but in the other direction. So you can see the slope definitely not as intense. So the dry line moves east during the day, and then the dry line moves west at night. What does that mean? Well, here's a look at it. You can see that dry line kind of looks like a brown warm front, if you will. But wind direction changes along that front more from the west, and when during the day, it's out of the south. So it moves during the day, and then at night, when there's very little movement, it kind of retrogrades, moves back. But you can see the moisture, what it gives you is a little bit of rising air along that slope typically allows for storms to develop ahead of a dry line. So there's not much when it comes to difference, I should say, when it comes to a cold front, warm front, and a dry line. It's just you don't see severe weather with it. You see clouds develop, maybe a few showers, but once the dry line moves in, you are going to see a difference in your dew points and the moisture. There isn't going to be much there. So there you go. Cold front, warm front, occluded fronts, stationary fronts, and dry lines. Might seem like a lot, but they do what their name says. Cold front brings in colder air, forces cold air down, forces warm air up. A warm front gradually brings in warmer temperatures and gives us a little bit more moisture, and dependent on the cold front, could give you severe weather. An occluded front is basically a cold front and a warm front together, and there's a very, very defined boundary between the warm air and the cold air, but you're not going to see severe weather there. You're going to see more showers and thunderstorms, but a big difference in temperatures once that occluded front moves through. A stationary front sounds just as you think it is. It doesn't move. It just hangs around until something forces it out. And with a stationary front, you see what that weather at that boundary is for a prolonged period of time. Not going anywhere. And then the dry line, yeah, it can scoop moisture up in the atmosphere, but once it passes by, you're going to see some pretty dry conditions for a good chunk of time. So there you go, kind of meteorology 101 when it comes to fronts and boundaries and what you can expect with them as they move through. We'll have more with Beyond the Forecast coming up right after the break. And welcome back, everyone, to Beyond the Forecast. Now, at the end of the shows, we always deep dive into Beyond the Forecast live streaming podcast. Me and meteorologist Haley Fischetti, we sit down every Tuesday at 10 a.m. and discuss with you live certain topics, whether it's a topic that we have for designated week or a topic that we let you vote on the Beyond the Forecast Facebook page. Now, we've had about 6 or 7 of these podcasts. We're currently still trying to work out getting them to Spotify and Apple Podcasts, anywhere where you take in podcasts. They are currently all living on the 910 News YouTube channel as well as the Beyond the Forecast Facebook page. But as we move along here, we'll start getting more consistent as we do finish our move here very shortly. So, with all that being said, let's jump into one of our podcasts and show you a little segment from that. Check it out.
That's why just kind of making it a full circle of climate change when we talk about warming up and everything, and we are seeing more just an increase of warmer temperatures, it starts to wake up a little bit more of the bacteria, waking up invasive species, which is why we get nervous when we talk about invasive species, because that's could impact your trees, your bushes, your gardens, algae blooms, all that. Those are all invasive that as we get warmer, you're going to start seeing. It's kind of like when everyone gets sick when we start to get warm again in the season. I always call it the season change sickness because all the bacteria are waking up and now everyone's getting sick again.
And that's one thing with 4 seasons, right? I mean, you tend to see that. But let's continue on the path of climate change.
Yeah.
The warmer you get, you start helping certain species out that weren't in your area before. Most
bacteria, most viruses, most everything when it comes to climate change feed off of warmth.
Right.
We talk about thunderstorms. We talk about everything. Right. Everything feeds off of warmth in our atmosphere, and we're just seeing warmer conditions.
We are. And that's an undeniable dispute. You look at the global temperature charts or what the
climate stripes.
The climate stripes.
Yeah.
The color stripes. And yes, we are much warmer than we were 150 years ago. Which, yes, Earth warms up, goes in warm phases and cold phases.
Ebbs and flows, yeah.
The problem is it's getting farther north. So you're seeing those warm lines much warmer because the majority of the globe is much warmer than it was 150 years ago.
Right.
That is climate. It's the data is saying, hey, you were much warmer now.
The point we were here 50 years ago is now higher than where we are now.
And now that's when you start asking questions of why. But when you start asking questions of why, you start seeing that, yeah, you're now warmer at this longitude. And this is, I can attest to this, and it is no secret. Northern Michigan, you're seeing the warm line get farther
100%,
north.
Yeah.
And that is opening the door to certain species that weren't here before.
Yeah.
Oh, hey, this is warmer now. I can thrive in this area.
Exactly.
Oh, there's a bunch of stuff for me to thrive on.
Changes our climate, our bioclimate.
Right.
Now, those are two different things. We have the biodiversity climate, and we have, obviously, climate in the...
So there you go. The Beyond the Forecast live streaming podcast, and we will have much more from that coming up here very shortly as we complete our move. But for meteorologist John Gross, meteorologist Haley Fischetti, I am Chief Meteorologist Michael Stevens. Thank you so much for joining us on Beyond the Forecast. We will catch you right back here tomorrow at 4:30 for more science and weather. Be good, stay safe, take care. We'll catch you all tomorrow. Bye, everybody.